Welcome. In this lecture, I want to introduce M2Z, or Z, we're in Canada. The reason for this is a really great example, and then we're going to kind of go through how to prove in this particular circumstance that we're going to have a ring. And so we're not going to go through all of the steps of proving this, but I'm going to do several samples. And it's a great one because you can transform a matrix into kind of a generic form, and you're going to see how that's useful in doing the proofs. That's going to be something that you're commonly going to want to do. Okay, so what is this? So the 2 tells me 2 by 2 matrices, and then the Z is for the integers, tells me that my coefficients have to be in the integers. So just in terms of notation, so we have, going to use a little notation here. So we're looking at the set of all. So we have A, B, C, and D. So these are 2 by 2 matrices, you can tell there. So the set of all 2 by 2 matrices such that, and now what we're going to require is that A, B, C, and D are elements of the integers. Okay, so remember this is like the set of all, right? These are telling me that I'm talking about the set of all, right? And this is just such that or satisfying. Okay, so this is what it is a set. We're also going to have, well, to give some examples first. So examples would be, well, one example actually I want to kind of do these in red. So one example is we do have 0, 0, 0, 0. That's totally okay. We also have, we have what's going to be the identity matrix, because you multiply it by anything, it stays the same. You could have things be negative, or there's all kinds of things we can do here. We have you could have -5, and then 3, and then 1,000, and then -67. Okay, these are totally fine as long as they're all integers. And then some non-examples would be what can I not have? So let's do these in another color. I'm doing blue. I'm going to use blue here. So something I'm not allowed to have. I can't put pi here. Right? I can't do that. I can't do. So these are non-examples. These are not actually in this ring. I couldn't do E or -E. Right, those would be problems. In fact, even having, I can't do 3/5. Right. Okay, so these are what these matrices are going to look like. And now I have some notion of addition. So how do I add these? So what if I wanted to take, actually let's do this in yellow, so this is going to be my addition. Okay. So what if I had, and I'm going to do these in the generic form. So if I have A, B, C, and D, because it's like kind of a generic one. I don't know what those are, but I can still tell you how the addition works. And then if I add to it A, B, C, D, E, F, G, H. Notice this is not the E like that. E, now it's being used kind of like a generic element of the integers. Okay, so if I want to add them like this, so what do I get out? Well, it kind of starts with, it's like you have A and B and C and D, but then you're going to have to add to each of them the corresponding coordinates. So A, and then we add E, and then B, we add F, C, we add G, and D, we add H. Okay, so you just add coordinate wise. So we add coordinate wise, we might say, or entry wise. Okay, now for multiplication, we'll do multiplication in another color. Do it in blue. Okay, so now we take, what happens if I want to take A, B, C, and D, and then I want to multiply it by, we'll do the same one, we'll do E, F, G, H. It always helped me, I don't know if this is actually going to help others, but I always felt like it helped me, which was this kind of picture of going, so I go like this and then I fall down the hill. So I go, so A gets multiplied by E and B gets multiplied by G. So I'm going to add this too. So A gets multiplied by E, B gets multiplied by G. We add this, right? This is just standard matrix multiplication, but in case you're less familiar with it. And then we have, so this one goes like this, then this one goes like this. Again, it's kind of sliding off the cliff to over here. So now I have A and B. And now I'm adding, right, these are multiplied by F and H. Okay, and then I have, so now I'm doing kind of another sliding kind of thing. So I'm going to have C and D and C and D. And now, first it slides down the first one, so I get E and G. And then it slides down the second one, so I get F and H. Okay, so that's just your standard multiplication. And we'll show examples of this, but it will be important that this multiplication is not commutative. Okay, so and we'll all kind of show this. Okay, great. So this is going to end up being a ring. We'll go through some of these properties. We're just looking at matrices, 2x2 matrices where the entries are integers. And we're going to add and multiply just like you typically do with matrices. When you add, you do it like in a component or coordinate or entry-wise. And then when you multiply, you do the kind of like slide off the cliff, kind of slide off the cliff and slide off the cliff. I think I've seen people kind of put this slightly down so that it's easier to see that. Okay, so I hope that made some sense, and I will see you in the next lecture.